We wish to use this data as an example of exponential decay. It is in fact a radioactive decay where n is the radioactive count rate as a function of time t. And we wish to fit a nonlinear exponential decay curve to this data. So we go to Stat, Regression, Nonlinear Regression. The response is the count rate n, and then we have to enter the expected function. We can do this in three ways. We could use a catalogue of standard functions, and for example the exponential decay function would be a constant theta times exponential of a second constant theta 2 multiplied by x, which in our example would be the value of t. Alternatively, we could use the calculator to derive the relevant equation using standard functions which are given in this function library. Or alternatively, we can enter the equation directly, which we will do, as being a constant a multiplied by exponential, open brackets, a second constant b multiplied by the value of t, and then close brackets. We must also enter the starting values of these parameters because the analysis will do an iterative measurement to move from a starting value to a best fit value. So under parameters, for our function a exponential bt, we will start with a guess for the value of a of 50, and for b we will enter a value of minus, because it is a decaying value, minus 0.5. We click OK, and then we run the analysis. In this graph here, we see that the analysis has calculated a best fit equation of n is equal to 97.86, which is the best fit value for a, times exponential minus 0.476, which is the best fit value for b, times t. And then it plots this best fit exponential decay line through the data points. We can also see the numerical values recorded in the session window, which has recorded our starting parameters of a of 50 and b of minus 0.5, and the final best fit exponential decay equation for the final value of a of 97.86 and b of minus 0.476. It also records these values again together with the standard error in the values. It also shows the number of iterations that were required in the analysis to get to the final value, showing that it required 6 iterations, which is only a few iterations, but that is not surprising because we started with a value of b, which is very close to the final value, requiring only a few steps to go from the initial estimate to the final best fit value.